Welcome to The Explainer. Today, we're breaking down one of the most powerful tools out there for making sense of our incredibly complex world. We're talking about a tool that learns, that adapts, and that finds patterns we just can't see on our own. I mean, think about that question. We're surrounded by systems that are so intricate, so interconnected, that our old-school ways of analyzing them are starting to break down. We're just swimming in more and more data, but a lot of the time, it just feels like noise. You see this in medicine, right? We've got electronic health records, genetic data, real-time info from our smartwatches. It's a literal ocean of information. But how in the world do you connect all those tiny dots to actually predict and prevent disease? Or take a look at our energy infrastructure. With solar, wind, and tons of electric vehicles plugging in, the grid has turned into this incredibly delicate balancing act. Just one small fault, one unexpected surge, and you could see these massive cascading blackouts. And then, of course, there's our digital lives. The adversaries we face in cyberspace, they don't have a rule book. They are constantly changing their tactics, always looking for new weak spots, way faster than we can keep up. So to deal with all this, we need a totally different kind of tool, not one that just follows a list of instructions, but one that can actually learn from all this complexity and adapt. And that's where the neural network comes in. And here's the absolute key. Unlike a traditional computer program that you have to give rigid step-by-step rules, a neural network learns directly from the data itself. It's built to find those subtle, messy, unpredictable connections, the kind of stuff that our own brains or older computer models would almost certainly miss. Okay, so how does this actually play out in the real world? This isn't just some theory locked away in a lab. Let's look at a few examples of these amazing digital brains out there in the wild, solving some really tough problems. All right, let's jump back to healthcare, because this is where neural networks are helping doctors make decisions that are more precise, more personalized than we ever thought possible. Just look at that number, 96%. By analyzing the incredibly complex brainwave patterns from an EEG, a neural network can learn to spot an epileptic seizure with that level of accuracy. I mean, think about that. That kind of precision can literally be the difference between getting a life-saving warning and having a crisis. It's a game changer. And this is really their superpower, synthesis. They can take all those different data sources we talked about, your medical records, your DNA, your daily habits, and fuse them all together to create this complete picture. That's how they help doctors manage crazy complex conditions like diabetes or stroke. Okay, let's switch gears to the energy sector. Keeping our power grid stable is, no joke, one of the biggest challenges we face. And yep, neural networks are becoming a huge player here too. You know, the whole game with power grids is balance. So neural networks are being used to predict how much energy huge fleets of electric cars are going to draw. But even more important, they can analyze the stability of the entire grid in real time, helping it adapt on the fly to the fluctuating power coming from solar and wind. And finally, let's talk about protecting our digital world. When you're up against cyber threats that are always evolving, you need a defense that can evolve right along with them. This number is just, wow, 99.3%. That's the accuracy a hybrid AI model can get in sniffing out cyber attacks. The way it works is pretty cool. It first learns what normal internet traffic is supposed to look like. And once it knows that, it can spot anything that looks weird, those little digital fingerprints of an attack, with just incredible precision. So that's what they can do, and it's pretty amazing stuff. But how do they actually learn how to do it? Well, it's not magic. It's a very careful, deliberate process of training and fine-tuning. Everything kicks off with something called a data pipeline. Just think of it like a chef prepping ingredients before they cook. You can't just throw raw, messy information at the network and expect a good result. You know the old saying, garbage in, garbage out. It's absolutely true here. So it's this 4-step recipe. First, you capture all that raw data, EEG signals, photos, whatever it is. Second, you have to clean it up, filter out all the noise. Third, and this part is so important, you extract the most meaningful features from that data. And only then, once the data is clean and packed with good information, do you feed it to the network to start learning. But there's this huge trap you have to avoid during the learning process. The goal is what we call generalization. Think of it like studying for a test. Generalization is when you actually understand the subject so you can answer any question they throw at you. The trap is called overfitting. That's like just memorizing the answers to the practice questions. Sure, you'll ace the practice test, but you're going to bomb the real exam because you never really learned the material. And that ability to generalize, to learn the real patterns from the noise, that's what really sets neural networks apart from the older, more rigid ways of doing things. It's why they are the future of this kind of analysis. Let's just put them side by side. On one hand, you have traditional models. They're great for simple, predictable systems where the rules are clear. But on the other hand, neural networks absolutely thrive in the chaos and messiness of the real world. They can handle all kinds of data, they adapt when new information comes in, and they don't force us to guess the rules up front. This quote just nails it. Neural networks are not merely computational entities, but foundational pillars. They're not just another tool in the toolbox. They represent a fundamental shift in how we solve problems. It's like having a whole new way of seeing the world. And get this, the future is even more exciting. The real cutting edge is in what we call hybrid models, combining neural networks with other advanced AI. We're talking about things like using them with reinforcement learning to build smarter robots, or with something called GANs to detect crime. These hybrids are what will push the boundaries of what we think is even possible. So, if there's one thing to take away from all this, it's this. For the first time in history, we have a tool that's truly capable of finding the hidden patterns in the unbelievably complex systems that run our lives, from our own biology to our global infrastructure. And that leaves us with one last big question. We've built these incredibly powerful digital brains that are getting better and better at understanding how our world works. So the question for all of us is, where do we point them next? What's the most important problem they should help us solve?